Greetings, everybody. Today's topic is even and odd functions. We're going to look at what makes an even and odd function. So our learning targets here are important. A couple words I want to make sure I point out here. So we're going to be able to recognize even and odd functions. We also want to be able to distinguish between even and odd functions and what we call even degree and odd degree functions. So the word degree versus function is important here. Okay, so let's start with that particular word, even degree and odd degree. So we have even degree functions and odd degree functions. So the degree, remember, only refers to the highest exponent in each thing. And notice 6 is even, so we'll say that's an even degree function. Doesn't mean it's an even function. We'll just define that later. And over here, our highest exponent over here is 7, which is odd. So we call it an odd degree function. Some other examples would be like y equals x squared. That's an even degree function. And it happens to be an even function as well, as we'll see it's symmetrical about the y-axis. And then odd degree functions, again, here's another example, 3x to the third plus 2. Our highest exponent is odd. Over here, our highest exponent is a 2, so it's even. Okay, so next we're going to look at actually what makes an even function versus and an odd function versus just even and odd degrees. So even functions are pretty easy to visualize. They are symmetrical about the y-axis. So as we look at this example here, we've got the y equals x squared. And we notice the y-axis runs right down the middle here, and it's split on either side. So if we take a point on that function, on the graph, and we test it to see what happens. If I take this point right here, right there, let's mark it with an X, and then we've got this point over here. So those order pairs are 2, 4, 2 comma 4, and over here we have negative 2, 4. So it should be symmetrical about the y-axis. So only the x changes when we're looking at the same y. So when we look at the y equals 4, the x values are opposite of one another. Our example down here would be the same thing. We look at these 2 points here for the blue one. Okay, so this refers to this function right here, y equals negative x squared minus 2. And notice we have the points 2, negative 6, and negative 2, negative 6. And notice symmetrical about the y-axis. So those are pretty easy to determine from the graph, just looking at the graph. Okay, so let's turn our attention to what the graph of an odd function looks like. It's symmetrical about the origin, so that's important there. We want to think about symmetrical about the origin. So in this case, around the point 0, 0, and that's a little harder to see for students. I'm going to pick the point on this green graph right there, and this point down here. Let's list those order pairs out. So the first one here, this is going to be 1, 1, and notice this order pair down here is negative 1, negative 1. So notice it's symmetrical about the origin because the x and the y flip there. Okay, and you can see that in the graph there. So I'll mark that point one more time. Negative 1, 1. Negative 1, negative 1, and 1, 1. Then we'll look at our orange example down here. I've got this point here and this point here. So I'm going to list those points out. This one is negative 2, 1. And my other point that I'm testing to see if it's symmetrical, this one right here is at 2, negative 1. And notice both our signs switched. Our negative 2 became a 2, so this negative 2 is a 2. And that means if it's an odd function, our y must flip as well. So 1 becomes negative 1. So symmetrical about the origin. So be comfortable looking at the graphs and recognizing when you have an even function or an odd function. Okay, the next thing I want to do is look at what makes not an even function and not an odd function. So we looked at examples of even and odd functions. Now we're looking at polynomials here, the graph. On the graph, even though they might be even degree, so we'll look at this example here first. This is an even degree function, but notice it has an odd degree term in it, and that's going to mess things up. So when we look at our y-axis right here, you can tell our y-axis there that it is not symmetrical about the y-axis. And in fact, if we look at a point there, this point right there, 1, 5, there is no point negative 1, 5 over here that matches. There is no point like that. So this is not an even function, although it is an even degree function. Same with this example. We start with an even degree function, but it's been shifted right 2 units from the origin. So there's no way it can be symmetrical about the y-axis. Okay, so when we look at a y-axis, it's been shifted right. So that is not an even function. Again, remember, it has to be symmetrical about the y-axis. Okay, next we'll turn our attention here to examples of not odd functions, and we're looking at the graph still. And we look at this. This is an odd degree, but notice it has an even degree term in it. And so when we go to test a point, if I were to look at this point right here, right there, that point is 1, 3. There should be a point, if it's symmetrical, there should be the point -1, -3. And when I look at that spot, there is nothing there. So it's not symmetrical about the origin. Same thing over here when I look at this one. It's an odd degree function, but it's been shifted left 2 units, as we know from transformations. So it's not even going to go through the origin, much less be symmetrical about the origin. Okay, so we looked at graphs, how to tell whether a function is even or odd. Now we're going to look at algebraically how we prove that. So here's the statement that we're working with. Okay, so we're working with the statement here, right there. It says f of -x equals f of x. Again, we're going to rewrite this equation over here. I've got it in y equals, but remember that y, I did write it in y equals on purpose. Remember, y is the same as f of x. So this is our function here, -2. Okay, so what we want to think about with this one here is when we plug in a -x, do we get the same y out as when we plug in an x? So let's go back to our example here with our ordered pairs where it's symmetrical about the y-axis. For this example, we have the ordered pair 1, 2, which is right there. And then we have the other ordered pair here, which is -1, 2. So highlight here, important piece here. Let me get the right color. So we're going to do blue. Notice when I plug in the opposite of the x, I should get the same y out. That's the definition of an even function. So how do we test that? Well, we're going to use this little statement right here to plug it in and see what we get. So we know what f of x is equal to. So this right side over here, f of x, we already know it's equal to this. So when we plug -x into the function, like this, we should get the same thing back out. And we have to kind of be careful with some parentheses here because it starts with a negative out front. So when I plug a -x in that spot, we should get the same thing out. That's what we started with. Now, a negative squared is going to be positive, but we got to apply this negative on the outside. So this is still equal to -x squared minus 2. So when I plug -x in, I get the same result out. Now, again, it's sometimes easier to see with numbers. So I'm going to do an example here with some numbers and see if we get the same thing. So we're going to try to plug in -3 and see what we get out. Okay, so I'm going to make some room here real quick first. Okay, great. So when I plug -3 in here, let's see what we get out. So I'm going to put a -3 into this function and see if we get the same thing as when we plug in 3. Because that's what the statement says. We should get the same y out when we plug in the opposite x. All right, so we're going to, again, be careful with our parentheses. We've got a negative out front, and we have a -3 we're plugging in. We're squaring that, and we're taking 2 away. Okay, so when we square -3, we get +9. Then we apply the negative to it. So this is -9 minus 2, which equals -11. So when we plug in -3, we get -11 out. We can write that as an ordered pair. -3, -11. Now we're going to do the same thing with +3 and see what we get out. So again, we got a negative out front. We're going to use our parentheses carefully. 3 squared minus 2. And of course, 3 squared is 9. Apply the negative to it next. We get -9 minus 2, which is -11. So again, we'll write this as an ordered pair. When we plug in 3, we get -11 out. We've proven, using algebra, this is an even function. Okay, there's our one ordered pair, there's our other ordered pair, and we had another example up here where we did the same thing. Now we have to use the x version rather than numbers because sometimes numbers can be a little misleading because maybe one number coincidentally works out. Okay, great. So next we're going to look at what makes an odd function algebraically. Okay, so here's our last example. We're going to look at this odd function. Over here is the graph, and you can see it is definitely symmetrical about the origin. Okay, right here, this graph. And if you picked a point, you could test it. So I could pick that point right up there, which is going to be, that's going to be tough because it's decimals. Okay, so I went and grabbed us a better graph here. This we can see a little bit better with the points. So this is 211 in the top right, and then we have -2, -11. And you can see where the x's and the y's flip there. Okay, so we can see it on the graph that it's definitely an odd function. So now we just need to interpret this expression here, which says that f of -x equals -f of x. So how does that play out? Well, again, we're going to rewrite our y as f of x. And we've got our 0.125 x cubed plus x. Okay, so when we plug in the negative x, we should get the negative y out. That's what that's saying. So we're going to start with doing this equation, but again, we're going to plug in. So we know what f of x is equal to. So what if we were to do negative f of x? Let's see what that's equal to. So I'm working with this right side of this expression. What does negative f of x look like? Well, it's basically I'm going to take the negative of the whole function. So I'm going to take this whole function and apply a negative to it. Okay, so we're going to put this negative out front of the right side of the equation that I have here in yellow. And we're just basically going to distribute the negative to both terms inside there. So when we do that, it's going to switch the signs of both of these. So negative f of x is equal to negative 0.125 x cubed plus negative x. So what we hope is when we plug in negative x right here, this piece, we get out the same thing, because this is what negative f of x is. So let's try that. Okay, so this gets a little messy, so I made that a little bit smaller so we got some room to work with. Okay, so again, what we're hoping is that when we plug in negative x, we get this result out. So that looks like this, f of negative x, and so I'm working with this side now, and I'm going to plug in, instead of x, I'm going to put, so I'm going to start with my original function, which is this one. I'm going to put a negative x in that spot. So I've got 0.125 negative x cubed plus negative x. And we can see here that if we raise a negative x to the third power, that makes it negative. So I can put this negative out front to make negative 1.25 x cubed. And of course, this piece over here is negative x. Okay, so I got my final notation here. It's a lot of writing there, so I kind of compacted it down. And we can see that these two things are equal. So when I apply a negative to the whole equation like I did up here, so negative f of x, what I get is this box piece here in blue. And when I plugged in negative x to the equation, I got this box, and these two boxes are equal. So when f of negative x equals negative f of x, we have an odd function. Again, the graph is a lot easier to use, but you have to prove it algebraically as well. So that's your task. Okay, so that's our summary of even and odd functions. We also talked about the difference between even and odd functions and even degree and odd degree functions. Hopefully that helps. Have a great day.